Hi guys, today in this video we're going to go through the section of Unit 3 where we talk about solutions and mixtures and representing solutions with particulate diagrams. So go ahead and get out your notes, open them up to section 3.7 and we'll go ahead and get started. So a lot of these things in section 3.7 are a review of what we talked about with solutions last year. So last year we talked about how to calculate molarity. Molarity is concentration, and it's specifically the concentration of the number of moles of solute, which is the stuff that you have dissolved, per liter of solution. And so doing that calculation, really, we're just plugging it in. Obviously, if you're not given moles, you have to convert from grams to moles first and then plug it in. Have to convert from milliliters to liters to plug it in. But we do have a specific question here that we'll go through this example. What will be the concentration of chloride ions, Cl minus, in a solution that is made by dissolving 10 grams of zinc chloride in a solution that has a final volume of 500 milliliters? So the first thing that we want to think about is my formula for zinc chloride, because they give me the mass of zinc chloride. So I am going to need to convert that into moles. But when I have zinc chloride and I dissolve it in water, it breaks apart into zinc ions, which zinc has a charge of +2. And when it breaks apart into chloride ions, there are 2 of them. So I should have 2 Cl minus. That's going to be important when answering this question about the concentration of chloride ions specifically. But let's go ahead and figure out how many moles of zinc chloride I have first. So if I have 10 grams of zinc chloride, I just need to convert that into moles. So molar mass of zinc chloride is 136.29 grams per mole. That gives me 0.0734. Should be a 0.0734 moles of zinc chloride. Now, I want to figure out, since I'm dealing with concentration, it's not enough to just find moles. I need to go ahead and divide that by my number of liters. So 500 milliliters is 0.500 liters. That gives me a concentration of 0.147 molar. So 0.147 molar solution has 0.147 moles per liter. So going back up here, if my concentration of zinc chloride is 0.147 molar, but the question is not what is the concentration of zinc chloride, the question is what is the concentration of just my chloride ions. What I need to pay attention to is that for every 1 mole of zinc chloride, there are 2 moles of chloride ions. So I'm going to take that concentration number and I'm going to multiply it by 2. So 2 times 0.147, that gives me 0.293 as the concentration. So this is actually my final answer for the concentration of chloride ions in the solution. Concentration of zinc chloride, 0.147, but since there are 2 chlorides for every 1 zinc chloride, I'm going to go ahead and double that number. Okay, so for this example over here, how many grams of potassium chloride? I'm not going to go through and solve for the whole thing, but you will, if it's asking you to solve for grams, you need to solve for, that should be a multiplication sign. You need to solve for moles first, so molarity times liters. Once you get your number of moles, you can go ahead and convert to grams using your molar mass. So a very common question in dealing with making solutions will be to ask you guys to actually describe the steps necessary. So over here it says to list the steps necessary to make 250 milliliters of a 0.1 molar solution of potassium hydroxide. So if you're going to make that solution, potassium hydroxide is a solid. And so what you need to do is you need to figure out how many grams of that solid do I actually need. So you need to go through the process of, and I already did the calculation, so pause the video if you need to, and make sure you write this down in your notes. You need to calculate your number of moles so that you can calculate your number of grams of potassium hydroxide. And you do actually need to describe, like it'll ask you in the questions, what kind of equipment is important for you to have. If you're measuring a solid, I thought that was going to highlight. If you're measuring a solid, you definitely want an electronic balance to measure that amount of solid, so that 1.4 grams. So we'll need our electronic balance to do that. Anytime you are making a solution with a specific volume, so they told me 250 milliliters, you want to use a volumetric flask. Volumetric flasks are super accurate for measuring volume. They only have one line on the flask. That one line measures the exact volume that you need. So the expectation is that you talk about using a volumetric flask to make those solutions. You are then going to start out filling your volumetric flask just about halfway. So maybe you start out filling it to like right here. You're going to dump your solid in, let it dissolve, and then you're going to continue to add more water to the volumetric flask until you reach that 250 milliliter mark. So in addition to making solutions, we also have to know things about diluting solutions. If we already have a solution that has a certain concentration and we want to dilute it, really all we have to do is we have to add water to lower the concentration. So our dilution equation, M1V1 equals M2V2, all of these solution equations, by the way, your calculations for molarity, moles divided by liters, this dilution equation, these aren't given on your reference sheets, so you are expected to know them. It says what volume of 1 molar HCl should be used to make 250 milliliters of 0.2 molar HCl. So I'm starting with 1 molar, so that's going to be my M1. I want to figure out what volume of that do I need. And I'm trying to make a solution that has a molarity of 0.2, and that volume is 250 milliliters. I can go ahead and solve for V1, and that gives me 50.0 milliliters of 1 molar HCl. So if I need 50 milliliters of 1 molar HCl, then you'll also need to know like how much water do you need to add to that? Well, if my solution is 250 milliliters, then I'm going to add 50 milliliters of HCl to 200 milliliters of water. And we always add acid to water. So if we add it to 250 milliliters of water, then together my solution will have a volume of 250. So when you're asked to answer a question about listing the steps necessary to dilute solutions, you still want to make sure, just like on our previous question, you still want to make sure that you talk about using your volumetric flask. So if I'm going to make a 500 milliliter solution, that means I want a 500 milliliter volumetric flask. You fill it about halfway. You do need to calculate how much of the concentrated acid you need to add to it. You'll add some water. You do need to mention the fact that you're going to be using either a graduated cylinder or a volumetric pipette. Both of those things are accurate for measuring the amount of concentrated acid that you need, and then you'll add that to the water in your volumetric flask to get the correct volume. Okay, so moving on to 3.8, we are dealing with representations of solutions with particulate diagrams. And so basically drawing pictures, we need to pay attention to when we're dealing with solutions. There's going to be water molecules that we draw quite a bit. So we have oxygen, we have our 2 hydrogens. We need to make sure we remember that our oxygen is the negative side of the water molecule, and hydrogen is the positive side based on electronegativities. Oxygen is more electronegative, so that side will be negative. When we have those molecules in a diagram like we have on this slide, we need to make sure that our water molecules are facing the correct direction. So like if I have silver and it's positive, then that means the negative side of my water molecules need to be facing silver. If the positive side is facing silver, then it's wrong. because we know that opposite charges attract and like charges repel. So the positive side of my water molecules will not be facing positive ions. So those should be crossed out. Same with nitrate over here. Nitrate is negative. So that means my negative part of my water molecule, which is oxygen, will not be facing that. It'll be the positive sides of my water molecule that are facing nitrate. Okay, so you will be asked to draw water molecules around ions. It's a super common question, and it'll tell you usually how many to draw. But calcium is positive, so that means I need my negative oxygen to face my calcium ion. So it should look like that. So we have this last example, these last two examples, and then we'll be done. So we've got equal volumes of solutions in two different vessels. Represented below, compare the compound formula and the molarity of the solutions. Okay, so anytime we have circles in a diagram, we should always count them. So the dark circles are representing our positively charged ions, and our clear white circles are representing our negatively charged ions. So in vessel number 1, I have 1, 2, 3, 4 positives, okay? And sometimes it helps just to cross them out while you're counting them, just to make sure you know that they got counted. So 4 positive ions, then I have 1, 2, 3, 4 negative ions. And what I'm going to do is I'm just going to go ahead and call my positive ions X and my negative ions Y. So since my ratio here is 1 to 1, I have 4 of each. That formula is just going to be XY. Now in vessel number 2, I have 1, 2, 3, 4, 5, 6, 7, 8 positive ions. And then if you went through and you counted all of those clear ones, there are 16 negatively charged ions there. So if I want to come up with that formula, I have 2 negatives for every 1 positive. That formula is going to be XY2. Now, if I have to compare their concentrations, I'm going to look at my X's because they're the ones that I only have 1 of for each formula, and that doubled. So what that means is that my molarity, well, we'll say, how does it say? Compare the compound formula and the molarity. So the molarity is going to be doubled because I have twice the amount of X ions. And then the formula is also different because of that ratio of negative ions to positive ions. And in our last example, we have, it says the drawing below represents 0.1 molar of magnesium chloride, and we want to draw a particulate diagram that shows 0.5 molar. Okay, so I've got 0.1 molar right here. I want to draw a similar diagram, but not 0.5, 0.05. Okay, so what I need to know is if I'm going to draw the particulate diagram for something that is 0.05 molar compared to 0.1, it's going to be, the concentration is going to be cut in half, right? So if I have 2 magnesiums on the left, then half of that, I should only have 1 magnesium over on the right. If I have 4 chlorides on the left, then I should only have 2 chlorides on the right. So this is still magnesium chloride. The ratio of chloride ions to magnesium is still 2 to 1. But my concentration is cut in half. My number of each of the ions is half as much as it was over on the left side. Okay, that is it for your notes on solutions and representing solutions with diagrams. So 4D in your assignments is going to be practice calculations with molarity and dilutions. So I will see you guys in class.